A painful truth must be faced by anyone who believes that science has discovered new explanations for the universe. Everything has gotten worse these days. Space exploration is undergoing a revolution thanks to James Webb. This was not what everyone had anticipated. Everyone was understandably thrilled when this feat of human engineering started operating in space in the summer of 2022. The most recent photograph, with previously unheard-of resolution and detail, was eagerly anticipated by both scientists and amateur astronomers. Located far out in space, Webb's razor-sharp eyes were trained on parts of the universe that had never before been observed by humans. James Webb Space Telescope was designed to observe the universe in the early stages following the Big Bang. It was intended to investigate the farthest galaxies, reveal the universe's initial stars, and, at last, provide answers to the numerous mysteries concerning the creation of our amazing planet. So far, Webb is doing a fantastic job. By studying the first stars, humanity hoped to gain a better understanding of how matter and everything we can see and experience today evolved. In fact, Webb is doing his job so well that thousands of scientists on Earth who thought they already knew everything about the universe are now confused and shocked by what they see in Webb's high-resolution images does not fit the picture of the old cosmology, and many researchers these days have to admit that they were wrong for decades. We also somewhat hoped that Webb would not only confirm the theory of the Big Bang, but perhaps also provide us with the first clues as to why the universe was created and what role we play in it. But now we are faced with a mountain of even more questions. Quote from Roger Penrose: "Well, first of all, it's a Big Bang model. In other words, there was a Big Bang, but the Big Bang was not the beginning." One person who is not shaken by the upheaval in astrophysics is Roger Penrose, the Nobel Prize winner and Knight of the British Empire. Was certain that there was a Big Bang even before James Webb's launch. But it was not the beginning of the universe, but rather a brief interlude. According to Penrose, there are many universes, and our own, which we are experiencing now, is a successor universe of probably countless previous ones. At the end of a life cycle, the universe collapses, remains for some time in a state of perfect equilibrium of all forces, and is then reborn in a silent bang. Penrose published his work on the cyclical universe in 2015, and thanks to Webb, his theory could now be confirmed. The facts at the moment are that the James Webb Telescope has shown us so many old structures that were far too advanced to fit into the picture of the old cosmology, the history of the origin of matter, and possibly also assumptions about the age of the universe are therefore wrong. Stars may have evolved much faster and more complex than previously assumed. In Roger Penrose's universe, this effect may be due to the fact that a baby universe does not start from scratch. It brings with it the blueprints and basic structures of the old predecessor, cosmos, and could thus assemble new matter far faster and better than we previously thought. Textbooks will almost likely have to be rewritten now, but at the moment it is still too early for this process in schools and universities around the world. In these days and months, we will probably hear phrases like "we don't know," or until James Webb started, we assumed it was one way or the other. But now everything is different, and Webb's revolution in cosmology is far from over. It has been proven that 771 trillion stars and thus star systems have simply disappeared. We have another sensational and recently published image from the James Webb Space Telescope to thank for this incredible revelation. Using comparative data from Hubble and old star catalogs, the images have revealed that over 771 trillion stars have simply vanished from our universe. When stars disappear, it also means that all their planets have disappeared with them. Stars normally disappear after a long period of brilliance by burning up as a supernova, but these stars did not explode. Their disappearance happened suddenly, without any comprehensible physical reason. This mass event contradicts one of the most fundamental laws of physics, the law of conservation of mass. This law states that mass can neither be created nor destroyed, but only transformed from one form to another. When a star explodes, it ejects all its mass into the universe, and this mass then serves as a building block for new matter elsewhere. Webb's discoveries around the ancient and actually two advanced objects and structures, as well as the discovery of the vanished stars, show us that our previous formulas and laws must be flawed. Our entire study of the universe is based on such laws. We cannot study most phenomena ourselves on sight. We can only observe their light, analyze their movements, establish connections, and derive laws. If these laws can also be applied to other phenomena, they slowly become truths. But if what is happening now, thanks to Webb, happens, we have to realize that our conclusions and laws were probably not entirely correct. Scientists find it difficult to explain how such a large number of stars and planets could simply disappear from the universe. Were they destroyed, or did they simply disappear from our field of vision for some as yet inconclusive reason? Some theories suggest that advanced alien civilizations can use stars as power plants by building gigantic spheres around the stars, and this could be the very thing that is hiding the stars from us. Ideas of alien colonies converting entire star colonies into gigantic energy suppliers have so far not suited conservative scientists at all. Just as Roger Penrose's ideas about cyclical universe have largely met with fierce resistance. But Webb's revolution in science is now making more room for these theories, which had previously received less attention. And the concepts are being viewed with a new openness. Isn't it captivating to think that it is almost only light that tells us these exciting stories of the universe? The magic of light plays a central role in astronomy, as it is the primary messenger that brings us stories from the depths of the universe. In fact, every image we see of the universe is a play of light reaching us across elusive distances. Light is not only the aspect that makes creation visible at all, but also an elementary carrier of information. Today, it is only through light waves that we learn details about the chemical composition and physical states of distant stars and galaxies. Light also tells us about the history of movements and developments in the cosmos. As light takes time to reach us, we can see billions of years into the past with the help of light traces. Light that hits the mirrors of the Webb telescope may have been sent on its journey thousands or billions of light years ago. This light provides us with a perfect imprint of bygone eras. The James Webb Telescope uses the properties of light in a particularly revolutionary way. Unlike its predecessors, which mainly observe invisible and ultraviolet light, the new telescope is designed to study the universe in the infrared range. Infrared light can penetrate cosmic dust clouds that otherwise absorb light in the visible range, and infrared light is more often emitted by colder and therefore often older objects in the universe. The Webb telescope is therefore perfectly suited to peering into the earliest and therefore most distant epochs of the universe, time so far back that the universe was in its infancy. These light signals enable the telescope not only to image stars and galaxies, but also to provide precise spectroscopic data. Thanks to this technology, we now have perfect analysis of the composition of different stars, or even exoplanets in our hands. These data are particularly important for testing and improving our models of the physical processes in the universe. We know that what we can see also deceives us, and what we see is ultimately light. So can the light we receive from the cosmos also deceive us? Yes, it definitely can. Astronomical observations can also be affected by various phenomena, such as gravitational lensing. In this effect, the light from massive objects in space is bent, and objects near these bends can be distorted, enlarged, or even imaged several times. Stars then appear far larger than they are, and galaxies appear with an exact twin or triplet. Such effects are fascinating and challenging at the same time, as they affect the accuracy of our measurements, and thus our understanding of the scaling of the universe. Another exciting topic related to the perception of light in the universe is the redshift light from objects moving away from us is shifted to longer, redder wavelengths. We know this phenomenon as the Doppler effect, and it is considered key evidence for the expansion of the universe. Among other things, it has been used to measure the rate of expansion. These measurements, in turn, support the theory of the Big Bang, which states that the universe emerged from an extremely hot and dense state. However, there is also a problem because the measurements provide results that differ so greatly on different scales that doubts have arisen about the redshift as a reliable indicator. It is possible here, too, that we have been deceived by light. Today, there are increasing doubts that the universe is really expanding. Literally, it has been proven that the universe is expanding faster and faster in some places instead of slowing down. Since James Webb discovered galaxies that are 13.6 billion years old or even older, we also have to ask ourselves whether our methods of determining the age of these galaxies are correct. Here again, astronomers use the redshift. The higher the red component, the further away an object is said to be, and therefore the older it is. Galaxies take billions of years to develop, so the age of the galaxies does not match a Big Bang that is supposed to have taken place just 200 million years earlier. Perhaps we are being deceived or misinterpreting light, and we need to find out why this is the case. Subscribe to the channel now and be part of every new video.